For these experiments, my test bench has a Allen Bradley Micrologix 1100 PLC, an Allen Bradley PowerFlex 4M VFD. I have a Foxborough CFT10 displaying controller with a Foxborough CFS10 Coriolis flow meter. Attached to that I have a Foxborough IGP10 pressure transmitter, and the whole system is set up to experiment with PID tuning and functions under pressure set points and flow set points. The inputs and outputs on the PLC have selector switches and start-stop buttons to start the whole process and switch from pressure mode to flow mode. The outputs just give me some indicator lights showing what position I'm in, shows me if the VFD is in a fault state, and what have you. So if we come in closer, there's the Micrologix PLC with the VFD. Here's a Foxborough IGP10 along with the display that is hooked up to the Coriolis flow meter. On these set of screens here I have Micrologix 500 Pro looking at the program with my set points and my PID. On this screen here I have another edition of Micrologix 500 showing me the graph of my inputs and outputs for PSI, VFD, speed in, speed out, flow along with my set points. Right now the system is operating in pressure mode. So down here on the lower portion of this graph is my pressure settings. The first line is my speed feedback, and underneath of that is also the speed set point for the VFD. The purple line is the PSI set point, and just underneath of that is the blue line showing me the PSI. So let's work with those first. So right now I have a pressure set point that I want to maintain of 1.5 PSI. I'm going to change that to 2 PSI and we'll see how the PID runs. So the purple line is my pressure set point, went up. The blue line just underneath of it is the PID, of tracking my set point with my pressure value as my feedback. Now on the back of my Coriolis flow meter, I also have the VFD hooked up to a pump, by the way, that's circulating water through this whole system into a bucket and then right back out again. So on the back of the Coriolis flow meter I have a little quarter turn ball valve that I can disrupt my process to see how the VFD reacts to that. So let me give it a little bit of a change now. There, I cut back on the flow, the pressure went up, and we can see the PID function bringing the pressure back down to my set point. And there it is, right back in line again. When we open the flow back up, we saw the pressure drop. We can see the speed of the VFD picking back up, and we can see it recovering again. Now the top of my graph has a green line, which is the flow from the Coriolis flow meter, and a white line just above that, which is the flow set point. So right now I'm going to switch the process over to flow mode, and because I don't have a bumpless transfer set up, we can see that my process variables are taking a plunge, and then the flow PID is working on the flow to bring that back in line with the set point. And I am no means by expert at tuning. This is what this whole apparatus is for, is to experiment and test and get better. So So it's a little choppy, not a great recovery, but it's back in line. My flow set point is 0.48 gallons per minute. So I'm going to change my set point to 0.4 gallons per minute, and we'll see how the PID reacts with that. So there's my set point change, and the green line is the flow. It plunged. Now I got a little bit of an oscillation going because my PID is not tuned really well, and it's a very sensitive signal coming out of the CF10 controller on the flow meter, which makes it nice because it gives me a lot to experiment with. Yeah, it didn't do too bad, so I'm going to change the valve position on the back of the flow meter and disrupt my process and see how the PID recovers. So the valve is wide open right now. I'm going to give it some restriction. And we can see the flow rate just dropped off. The VFD is picking up speed to try to compensate for it with the PID. We can see the blue line went way above that. The pressure went up. And it looks like my flow valve is closed beyond the limits of the VFD to recover from. So I'm going to open up just a little bit. And there it is. Once again, my flow set point is 0.4 gallons per minute. And it looks like it caught up and it's maintaining it pretty well. So I've been doing all of this for about, in the span of my lifetime, if we put it in perspective, probably the last 20 minutes with PLC programming and instrumentation. So it's been a lot of fun. Thanks for watching.